today's lesson, lesson 1.5, we are going to talk about solving quadratic equations by finding the square roots. The first thing we need to do is talk about the vocabulary that you are going to see in this lesson. The first new thing that you're going to see in this concept, in this lesson, is going to be this sign right here. This right here is the radical sign. You will see it sometimes where it has numbers and other times it doesn't. If it does not have a number in this area right here, then that means you're looking at square root. If it has a number in here, then you are going to use that number, whether it's a 3, it might be cube root, or to the 4th root. But the biggest thing to know is that this sign right here is a radical sign. The next part of the vocabulary is to know that what goes inside the radical sign is called the radicand. What that means is that the number inside, we need to find what number times itself equals the number inside. When you find that number, you no longer have to keep the radical sign. It becomes, you can square root it and get an answer. Next we have rationalizing the denominator. What rationalizing the denominator means is that if you have a radical sign in the denominator, say 1 over square root 2, to rationalize it means you have to multiply top and bottom by your radical in the denominator. What that's going to do is cancel out the radical underneath, because now for this example we have square root of 2 squared. Square root canceled squared, so we would have 1 square root 2 over 2. And the last vocabulary is the conjugate expressions. Conjugate expressions. What that means is if you see, again, in the denominator, if you see like 1 over 1 plus square root of 2, the conjugate of that is 1 minus square root 2. Because based on this rationalizing the denominator, we have to get the radical sign out of the denominator. And because it's attached to this plus sign, we have to do the whole. And so we would multiply top and bottom by the conjugate, which is negative, to solve it. All right, at that point, what it's going to do is it's going to cancel out the, when we FOIL it, it cancels out the middle, which is the, which would be our bx. And so all we would have left is 1 plus 2. And so we could say 1 minus square root of 2 over, again, I'm going to go ahead and show this. 1 times 1 is 1. 1 times a negative square root 2 is a negative square root 2. 1 times a positive square root 2 is a positive square root 2. And then square root 2 times a negative square root 2 ends up being a minus 2. So my answer would be 1 minus square root 2 over this negative cancels out this positive, And so I have 1 minus 2, which is a negative 1. So that is how you would conjugate the expression. We looked at how to rationalize the denominator. We understand that the radical sign has to do with finding out what times what equals the number inside, which is the radicand. The first concept that we are going to talk about with properties of is properties of square roots. All right, and it's specifically when your a is greater than 0 and your b is greater than 0. The first property is the product property. The product property. And we know that the word product means multiplication. The product property shows that the square root of AB is the same as saying the square root of A times the square root of B. And that is the product property. Now, for an example, we can say the square root of 18 equals the square root of 9 times the square root of 2, which is equal to the square root of 9 gives us 3, and so we have 3 square root 2 as your answer. The second property is the quotient property. And again, when we see quotient, that lets us know divide. And so this one we have this square root of A divided by B is the same as saying the square root of A over the square root of B. So again, I have an example, which is the square root of 2 over 25. We can go ahead and rewrite that as the square root of 2 over the square root of 25. And we know that the square root of 25 is 5, and so we can say the answer is the square root of 2 over 5. So now that we have seen the product property and the quotient property, why don't we go ahead and do a couple of more examples, one of each. So the first example is going to be the square root of 8 times the square root of 6 equals. Now you'll notice that it is already in this square root of A times square root of B. What I want to do is first get it back into this square root of AB, and so I'm going to say the square root of 8 times 6 equals the square root of 48. Now, within 48, is there a number that is a perfect square root? So what you would have to do is start thinking about all the numbers that we use. We know 2 times 2, because remember, thinking back to our vocabulary, that a square root means a number times itself to equal the radicand. And so I know we can say 2 times 2 is 4. And so we know there's a 4 in there. But can we go farther than that? Can we say 3 times 3? 3 times 3 is 9. 48 is not divisible by 9. So let's go again and try 4 times 4, which is 16. 4 times 4 being 16, we have 3 16s within 48. So I can go ahead and rewrite that, this original radical as the square root of 16 times 3, which again, we can start back to here and say the square root of 16 times the square root of 3. The square root of 16 we said was 4 because we said 4 times 4 equals 16. So I can say 4 square root 3. And there is my answer for the square root of 48. The second example is going to be the square root of 5 over 36. Again, we know that when we have the radical, that means we need to rewrite it as a radical on top, which is the square root of 5, and a radical on bottom, which is the square root of 36. We cannot have a radical on the bottom of the fraction, which is the denominator. So the first thing I want to do is see if there is a perfect square within 36. There is a perfect square within 36, and it is 6. So we can go ahead and rewrite this as square root of 5 over 6. And there are two more examples of the product property and the quotient property of square roots. Now that we have talked about the properties, we're going to rationalize the denominators of fractions. And so what we're going to do on example 1 and another example is simplify. We're going to look at this and think back to our quotient property. And the quotient property states that the square root of 7/3 is the same as saying the square root of 7 over the square root of 3. Since the square root of 3 is not a whole number because nothing times itself equals just 3, we're going to have to rationalize the denominator. Remember, we do that by multiplying the top and the bottom by our radical. So now we have the square root of 7 times 3 over the square root of 3 times the square root of 3 is the same as saying the square root of 3 squared. So again, we can rewrite that, and we know 7 times 3 is the square root of 21, and then square root cancels out square, so 3 is your new denominator. So we have just solved or simplified example 1. Example 2 is 5 minus 3 minus square root 7. So again, we think back to our vocabulary where we have the conjugate, because it has a radical in the denominator, but we can't separate because of the operation. So we can rewrite and say 5 times 3 minus square root 7 times, you have to multiply top and bottom by the conjugate, which is 3 plus square root of 7 over 3 minus square root of 7. So what I'm going to do is I'm going to go ahead and rewrite and say 5 times 3 plus square root of 7 over, and I want to go ahead and start using my FOIL method. So I want to do 3 times 3 gives me 9. 3 times a positive square root 7 gives me plus 3 square root 7. A negative square root 7 times 3 gives me a minus 3 square root 7. And then a negative square root 7 times a positive square root 7 gives me minus 7. So now I'm going to combine like terms ahead and distribute my numerator. So I have 5 times 3, which is 15. I have 5 times square root of 7, which is just a plus 5 square root 7. And so now we're going to look at the denominator. We want to combine like terms. So I have a positive 3 square root 7 and a negative 3 square root 7. So they cancel each other out. And what I have left is a 9 minus 7, which gives me 2. So there is my simplified answer to 5 divided by 3 minus square root 7. The next concept we are going to discuss is solving quadratic equations. We are given 2x squared minus 3 equals 87. What we want to do is solve for x in as few steps as possible. So the first thing I'm going to do is I want to go ahead and move my 3. Right now it's a negative 3. So in order to be able to move it to the other side of the equal sign, we have to add 3. So I'm going to add 3. So now I have 2x squared equals 87 plus 3, which is 90. The next step we want to do, again, we are trying to get x by itself. And so we're going to go ahead and divide both sides by 2, because the opposite of division is the opposite of multiplication is division. So now we have x squared equals 90 divided by 2 is 45. The next step we need to do is get rid of our power, which is squared. And so the opposite of squared is square root. So it's plus or minus square root 45. The reason why it is a plus or minus is because anytime you have an even exponent, that means a negative number times a negative number, that would give you a positive number. And then a positive number times a positive number still gives you a positive number. So anytime you were trying to cancel out square, you have to do a plus or a minus of the number. So now we want to think back into our product properties and see if there's any number within 45 that is a perfect square. So I'm going to go ahead and rewrite, because when I think of all the factors of 45, I think of 1 times 45, and I think of 5 times 9. Well, 9 is a perfect square, so I'm going to go ahead and write 9 times 5. And what we just went over with the product property says that what this means is I can redo this, rewrite it, and say that this is a plus or minus the square root of 9 times the square root of 5. What is the square root of 9? The square root of 9 is 3. So my answer would be a plus or minus 3 square root 5. So I just solved the quadratic equation of 2x squared minus 3 equals 87. I wanted to go ahead and solve one more equation for you, and this one has another step to it. 1/2 times w minus 2 squared plus 1 equals 4. So again, we want as few steps as possible to get w by itself. The first thing I want to do is I want to move my 1, because it's not attached to my w at all. So I'm going to go ahead, remember to move it on the other side of the equal sign, you have to do the opposite operation, which is -1. You do it to both sides. And so now I have 1/2 times w minus 2 squared equals 3. The next step that I want to do is multiplication, because right now it's being multiplied by 2. And so I want to go ahead and say, well, the opposite, you can say 1/2 is the same as saying that w minus 2 squared is being divided by 2. And so when you have a fraction, what you're going to do is you're going to multiply this whole by 2, or 2/1, which means you're going to multiply this side by 2. So what that does is cancel this out, and that leaves w minus 2 squared equals 6. So again, I'm still working toward getting my w by itself. The next step we need to do is get rid of our squared, because that links w minus 2 together. And so the opposite of squared is square root of w minus 2 squared. So that means I'm going to do, again, because it's squared, I have to say a plus or minus square root 6, because now this squared is being canceled by square root. The last step is to say, well, w minus 2 equals plus or minus square root 6, but I need this negative 2 to go to the other side. So I'm going to add 2 and add 2. And so my answer would be w equals 2 plus or minus square root of 6. Now, if you're trying to put your answer in like an SAT or an ACT, they're going to want you to separate that into 2 answers. So what you would do is say 2 plus square root of 6, or 2 minus square root of 6. And that is what your w equals in 1/2 times w minus 2 squared plus 1 equals 4.